Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 11.4, Problem 3. This is Section 11.4, Problem number 3. It says use the formula f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h to find the derivative of the function f of x equals x squared. And once you find that derivative, part A, find the slope of f of x when x equals 1, and then part B, find the slope of f of x when x equals 3. So let's start by finding the f prime. I recopied the formula below with different colors. So f prime of x equals the limit as h approaches 0 of f of x plus h, which I wrote in blue, minus f of x in red, and then h in green. I think of the formula as having 3 parts, so I put the 3 parts in 3 different colors. So I'm going to do f prime of x equals the limit as h approaches 0 of, and now the first thing I have to do is f of x plus h. So let's figure out what that is. So from the question, f of x is x squared. So let me write that in blue. F of x equals x squared. So f of x plus h equals x plus h, parentheses, second power. So the function says whatever the input is, raise it to the second power. So when my input is x plus h, I will raise it to the second power. So to do that, f of x plus h equals, the x plus h second power is x plus h times x plus h. So I have to do out that FOIL, first, inner, outer, last, like that. So x times x is x to the second power. X times h is hx. So that takes care of the x. I multiplied times both pieces in the second set of parentheses. Now the h times x is hx. And then h times h is h to the second power. And I have two hx's, so I can say that I have x squared plus 2hx plus h squared. Again, I have an hx in 2 different spots I combine to make 2hx. So now, as I fill out the formula for my f prime, my derivative formula, the part in blue, the f of x plus h, after doing some work and some simplification, is x squared plus 2hx plus h squared. So now I have a minus as part of the formula. Then f of x. F of x is given in the beginning of the problem. It's x squared. And then in the denominator, just plain old h. And now I will close the brackets. And now, to find the derivative, I want to take the limit as h approaches 0. And again, the problem is, I have h's in a couple of spots. The problem is a denominator. I can't just let the denominator run down to 0 and be undefined. So what happens is, I have an x squared in the numerator and a negative x squared in the numerator. I can cancel them. And now all the pieces left have an h. So what's happening is I want to take the limit as h approaches 0 of 2hx plus h squared over h. And now every piece in the numerator has an h in it. So I will factor out that h. So I want to take the limit as h approaches 0 of h times 2x plus h to the first. So the 2hx, when I take out an h, becomes 2x, and the h to the second power, when I take an h out in front, becomes h to the first power. And I still have the h in the denominator. And now h in the numerator that I factored out and h in the denominator can cancel. So now I want to take the limit as h approaches 0 of 2x plus h. Now that I have the h gone from the denominator, I can take that limit. This h out on the end, I can let it run down to 0, and I get 2x plus 0, or just 2x. So the answer for the derivative, or f prime, is 2x. So now, part A, it says find the slope of f of x when x is 1. So f prime of 1, that 2x becomes 2 times 1, or 2. And then part B, find the slope of f of x when x is 3. So f prime of 3 equals the 2 times x becomes 2 times 3, which is 6. So when x is 3, the slope is 6. So again, we didn't need to see the graph, but if you have f of x equals x squared, I do happen to know that that's a parabola that's centered at the origin. So what they're saying is, if you go over x is 1, the slope at that point is 2. And then if you go over 3, when x is 3, so say in line with the 3 here, the slope at that point is 6. You have different slopes at different points when you have a curve. When the graph is a straight line, the slope is the same at every point on the line. That's why it's straight. But once the graph starts to curve, different points have different slopes.